Hey, so I thought we could do a little review for your assessment on working with identities. Okay, so how about this one? Start with this one as better work. 1 over cosine x plus 1 plus 1 over cosine x minus 1 equals negative 2 cotangent x cosecant x. Take a moment to go through that. These problems. Okay, so multiplying by top and bottom by conjugate, or did you make a common denominator? Well, those are the two strategies I'd recommend at this point. Um, so this one needs a sine x minus 1. Please make sure you do it on top and bottom. Because otherwise, you're not multiplying by a form of 1. And then you're doing some bad math and you have to mark it wrong. So our common denominator will be cosine x minus 1, cosine x plus 1. And on top, we're going to have a cosine x minus 1 plus our cosine x minus 1. I think I did something wrong yet. Yes, these should be pluses. So these 1's cancel. Okay. I got 1 cosine plus 1 cosine is 2 cosine. And on the bottom, if I FOIL, I have cosine squared x minus 1. Now, this is almost that Pythagorean identity. Remember, that one is 1 minus cosine squared equals sine squared. And so in this situation, where we've changed the signs on both of them, we need to change the sign on this one. So we're going to have 2 cosine x over, not sine squared x, but negative sine squared x. Okay, and where do we go from there? I like the negative and the 2. That's good, because I need those. And somehow, I'm supposed to turn this into this. And so what I think I need to do here is to say that I've got cosine over sine and 1 over sine. How come? That's sine squared. I'm just breaking the sine squared down into sine times sine. I'm using one of those signs here with the cosine and pushing the other sign to the side. And why? Well, because cosine over sine is cotangent, and 1 over sine is cosecant. And I'm done. Okay? Please don't forget to show all your steps. Yeah, and please don't do this. Please don't do the person who does a couple of steps, gets stuck, goes to the end of the problem, and tries to work it backwards, and they kind of make up some math here that doesn't actually connect. Yeah. So here's the thing: math teachers can actually see that, and you're not going to get credit for it. So don't waste the time. I mean, you could be writing a poem. Yeah. Okay. How about this one? Cotangent theta over secant theta should equal cosecant theta minus sine theta. Hey, so which side did you work? Did you work this side or did you work this side? I don't care. I'm just asking. Just asking. Okay. Well, let's see what happens. Because I kind of want to work over here, but I'll work over here if you like. Oh, look. Yeah, no, that's correct. I think that's correct. Yes, that's correct. Okay, so cotangent is cosine over sine divided by 1 over cosine. Okay, so what if I do my flip and multiply? Cosine theta sine theta times cosine theta over 1. Well, that's going to be cosine squared theta over sine theta. Now, a lot of people get stuck around in a place like this, and so I might suggest to you, look where you're going. Use that strategy. Oh, look, somehow I've got two terms. Hey, this is sine, and this is 1 over sine. And I got the 1 over sine kind of thing going on here. But, yeah, so I need some more sine, I think. And I don't see any cosine stuff here, but I got lots of cosine stuff here. So I think I need to get rid of that. Oh, wait. Isn't there an identity for cosine squared? Isn't cosine squared equal to 1 minus sine squared? It sure is. So I'm going to take this cosine squared and replace it with this stuff. And so what's that going to get me? Well, that's going to get me this. And now, remember we had two terms. We looked over here and saw where we were going. Gosh, I think I want to split this fraction up into two pieces. One of them is 1 over sine. And the other is going to be sine squared over sine. Well, that's great, because 1 over sine is cosecant. And sine squared, well, I can take one of those with one of those. And so I'm just left with minus sine. And sure enough, that's what I'm trying to get. Okay? So for people who work the left side, that's what I might do. But what if you worked the right side? Well, let's see. Cosecant is 1 over sine minus sine. Okay, and I think, oh, I've got two things over here, but only one over here. So I'm going to use that strategy that says, hey, why don't you make a common denominator so you can turn this into one thing over here? Cool. So I'm going to multiply here by sine over sine. And so that's going to give me 1 over sine minus sine squared over sine. In fact, I think I want to write that as 1 minus sine squared over sine. What is sine squared? That's 1 minus cosine squared. Oh, look, 1 minus sine squared is here. So we could turn that into cosine squared over sine. And I know if I split up this into cosine theta over sine theta times cosine theta, well, now I'm looking at cotangent times cosine. Well, that's the cotangent I'm looking for. And cosine over 1 is the same as, remember, cosine is the same as 1 over secant, if we know our reciprocal identities. So this becomes cotangent, and this becomes 1 over secant. So we've got cotangent, cosecant, cotangent 1 over secant. There we go, which is cotangent over secant, and we're good to go. So you can work either side of these problems, and really, you should just pick a side, the side that feels most comfortable. For most students, it's the left side, but, you know, it doesn't have to be. How about this one? 1 over sine theta minus 1 over cosecant theta equals cosecant theta minus sine theta. Okay, give that one a try. It says sine theta, by the way. Yeah. We could make a common denominator. But I kind of want to say, hey, let's just think before we start doing. I got two terms over here, and I got two terms over here. So I'm not really keen to make a common denominator, because making a common denominator is what I do when I have two things, and I want to turn them into one thing over here. And no, I don't need to, no, there's two things over here. So why go from two things to one thing when you could just go two things to two things? In fact, don't we have a reciprocal identity for 1 over sine? That's equal to cosecant. And don't we have a reciprocal identity for 1 over cosecant? Sure do. It's sine. And we're done. Okay? Thinking is okay. Making mistakes is okay. Thinking is okay. These are not things to be ashamed of. Rushing to get something done, because you just want to get it done, sometimes that makes things take longer. Just, think, think, think. Okay, how about 1 over 1 minus cosine theta should end up as cosecant squared theta plus cosecant theta cotangent theta. In fact, I'm going to move that a little further over. Cosecant squared theta plus cosecant theta cotangent theta. Okay, so which side do you want to work? Yeah. Some people really do like working this side better. The more complicated the side, it's easier to turn into the less complicated side. Some people are looking at this and thinking about using the conjugate. And I think both of those are a fabulous thing to be thinking about doing here. So, yeah, if you haven't tried this yet, pause the video and give it a try. I'd like you all to get fabulous scores on this next assessment. Hey, welcome back. So let's try that strategy out first, where we make that, we multiply top and bottom by the conjugate. 1 plus cosine theta, cosine theta. Okay, so on top, I got 1 plus cosine theta. On the bottom, when I'm done FOILing, I end up with 1 minus cosine squared theta. Well, what is 1 minus cosine squared? I agree, that's sine squared. And so now we can split this up into two different fractions. And one of those would be 1 over sine squared, and the other would be cosine over sine squared. See where we're going with this yet? Yep. What's that? Cosecant squared. Now, this one is cosine theta over sine theta times another sine theta. That's cotangent, and 1 over sine, cosecant. I would certainly like the last line written, so I'm going to squeeze it in over here. Wish I hadn't done that. So I'm going to have cosecant squared theta plus cotangent theta times cosecant theta. And there. Okay. But what if we chose to work this side of the equation and tried to turn that into 1 over 1 minus cosine theta? Okay. Wonder which one is the easier path, or the more efficient path. So here I notice I could factor out a cosecant. You may have seen something else like, ooh, look, cosecant squared. I know that's cotangent squared plus 1. Maybe you could do that instead. This is going to give me cosecant plus cotangent. Okay. And then this, yeah, I don't know where that's going, but I am thinking over here of turning these into sines and cosines. Huh. Okay, well, since these both have a sign in the denominator, can I pull that sign out? I can factor a sign out of each of these terms, and that'll multiply this and become sine squared, 1 over sine squared. Here, I'm going to have 1 plus cosine. Okay, now, from this point, there's 2 different ways you can go, maybe 3 different ways you can go. Which one do you like better? So some people see the sine squared and they don't see any siney stuff over here. So they think, well, I see some cosine stuff and I see some cosine stuff. Maybe I should turn that into some cosine stuff. And so then they now have 1 over 1 minus cosine squared. And on top, we have that 1 plus cosine theta. Okay. Hey, that's a difference of squares. So if I factor that on top, I still have the 1 plus cosine theta. But now on the bottom, I've got 1 plus cosine theta, 1 minus cosine theta. And lo and behold, I end up with 1 over 1 minus cosine theta. And I'm done. So that's one approach where you turn this into cosine stuff. Another approach could be, oh, I see another approach. So I've got 1 plus cosine theta over sine squared theta. And I'm thinking, hey, what if I multiply top and bottom by the conjugate? 1 minus cosine theta, 1 minus cosine theta. Okay, so on top, I'm going to have 1 minus cosine squared theta. And then I've got sine squared theta, 1 minus cosine theta. But as so often is the case, I'm going to resist the temptation to distribute here. And instead, I'm going to say, hey, 1 minus cosine squared, isn't that sine squared? And if I give in to that temptation to distribute the sine squared, yep, most students don't see that you could cancel those factors out. So that's usually why I'm resisting that temptation to distribute, but I'm always foiling. Okay, so here are three ways of doing that problem. We'd like one of them comfortably, please. How about this one? Secant squared x over secant squared x minus 1. And that's supposed to be cosecant squared x. All right, I'd like to see that, please. Okay, so what'd you do? No, I see secant stuff here. No, I don't see any secant stuff over here. I see cosecant stuff over here. So somehow I'm going to need to go from things with cosine to things with sine. And that means that I need to, do some math. Secant squared minus 1. Isn't that tangent squared? Isn't that one of the Pythagoreans? I think so. And here we have secant squared. Okay. Well, I think I'm going to rewrite these in terms of sines and cosines. And now I've got that complex fraction thing going on. And so I can say, all right, well, I'll flip and multiply. 1 over cosine squared times cosine squared over sine squared. Oh, look, cancel, cancel. I now have 1 over sine squared, and that's equal to cosecant squared. And we're all done. So that's one approach. Some students want to take this and split it up into 2 fractions somehow. Yeah, you can't split this up into 2 fractions. 2 things on top, 1 on the bottom, you split. 1 thing on top, 2 things on the bottom? No, don't split that up. That's bad. Okay? All right. So how about this one? What if we had sine x plus cosine x squared plus sine x minus cosine x squared, and that should equal 2. No, really. All that's going to simplify to 2. So give it a try. Can't wait to see what you come up with. Okay. Did you foil? Did you foil? And by foiling, I don't mean do this, because that's going to be sad face. This is a binomial. There are 2 terms being squared here. And like we talked about in algebra basics, we can't just apply that exponent. If we had sine x cosine x and the squared, sure, that's sine squared x cosine squared x. But this is sine plus cosine squared. And you know that means that's foiling. You have to do some foiling. Likewise here. That's going to be sine x minus cosine x times sine x minus cosine x. So when I foil, I get sine squared x plus cosine times sine, so we have 2 cosine sine, plus cosine times cosine is cosine squared. Then we have our plus sign, and now we have to FOIL this one, which is going to be sine squared. Ooh, minus cosine sine, so that's minus 2 cosine sine. And then we've got minus cosine times minus cosine is plus cosine squared. All right, well, what do you notice here? Yeah, these are opposites. Plus 2 cosine sine, minus 2 cosine sine, all that cancels away. And so what am I left with? I'm left with a sine squared plus a sine squared, and a cosine squared plus a cosine squared. And so that gives me 2 times sine squared plus cosine squared. And we know that sine squared plus cosine squared is 1. And so we get 2 and we're all done. Someone just told me that they think of this in a different way. And then, in fact, that's just confusing to them. So here's what they said. They said sine squared plus cosine squared is plus sine squared plus cosine squared is, and that's 2. And I think I agree with them. I think that's faster. Good job. Thank you for bringing that up. All right. How about this one? What can you make of this? Tangent x over secant x plus cotangent x over cosecant x equals sine x plus cosine x. Now, just a heads up, yeah, I really don't want to try and turn this into that. I mean, you can, but I'm going to work over here. So give that one a try, and we'll talk about it in a couple of minutes. Or we'll talk about it right now if you didn't pause the video to do the problem. So I think when students look at this, I see 2 common responses. One is to make a common denominator. But again, I don't think I'm going to make a common denominator because I've got 2 things here joined with addition, and I got 2 things over here joined with addition. I make a common denominator when I'm trying to take those 2 things and turn it into one thing. That's not what I'm doing here. So don't. I mean, you can, but don't. Instead, let's go back to that first favorite, rewriting things in terms of sines and cosines. So tangent is sine over cosine, secant 1 over cosine, plus cotangent is cosine over sine, and cosecant is 1 over sine. Okay? So now let's do some flip and multiply. I'm going to have sine x over cosine x times cosine x over 1 plus cosine x over sine x times sine x over 1. And do you see it? And we're left with sine plus cosine, and so we're all done. Okay? I mean, you can make the common denominator. Don't get me wrong. But really, look where you're going. You've got 2 terms. When you make that common denominator, you're actually forcing yourself to take a longer journey than you need to. But if that's what you see to do, you should do that. Okay, how about this one? Sine x plus 1 over sine x minus 1 equals 1 plus cosecant x over 1 minus cosecant x. Okay, give that one a try. Okay, so what'd you do? Did you turn these into 1 over sines and then make a common denominator and flip and multiply? I see a lot of students do that. Let's see what happens to them. So they multiply here by sine x over sine x, here by sine x over sine x. And so those students end up with sine x plus 1 over sine x over sine x minus 1 over sine x. Okay. And then we would flip and multiply. Sin x plus 1 over sin x times sin x plus 1. These cancel, and I'm done. Now, I'd like to propose an alternative. Because of the parallel structure I see, then plus thing, then plus thing, then minus thing, then minus thing. I'm going to use that magic number 1 strategy. And magic number 1 strategy is something I actually have to think about. So remember, what's involved here is me saying, what do I have to multiply this by to turn into 1? And a lot of people are challenged by that. Yes, it'll work, and I'll tell you in a moment what that's supposed to be. Easier for people is to say, what do I have to multiply this by to turn into cosecant? Well, I have to multiply 1 by cosecant. So I'm going to multiply top and bottom by cosecant x. And when I distribute that, sine times cosecant is the same as sine times 1 over sine. And I get 1. Oh, well that's convenient. So this times this is going to give me 1. And this times this is going to give me cosecant. And this times this is going to give me 1. And this times this is going to give me minus cosecant. And I'm all done. Okay. I have a couple of notes here. I think these are things you might want to think about. Write 1 minus sine squared as a difference of squares. Okay. Not use your Pythagorean identity. That's not what this is asking you to do. This is asking you to turn that as a factor. So maybe we want to say factor this as a difference of squares. So, what's that going to look like when we factor it? 1 minus sine, 1 plus sine. Yeah, cool. No, there's nothing more I wanted you to do with that except realize that that is a difference of squares. When you see that, that is a difference of squares. I think you factor is a difference of squares. But why am I saying that? Because I think there's something on the next assessment where a student really needs to be able to see difference of squares. And I just wanted to remind you that you know how to factor difference of squares. Okay, let's look at this one. It's very interesting because the note here says break this into 2 fractions and then simplify. And I'll do that in a minute, but that's not at all what my brain is thinking right now. On day 5 of working with identities, my brain is thinking, hey, isn't 1 minus sine squared cosine squared? And so now I've got cosine squared over cosine squared, which is 1. But let's actually follow the directions. The direction said split this into 2 fractions. So our first fraction is 1 over cosine squared. And then we have this minus sign. And then we've got the second fraction, sine squared over cosine squared. Alright, so what is that? Well, 1 over cosine squared is secant squared. And sine squared over cosine squared? Yep, tangent squared. Oh. Well, that's one of our Pythagorean identities rewritten. I know, and if you don't recognize this one, maybe you want to say, okay, secant squared theta equals tangent squared theta plus 1. Remember that one, the first one. And let's put that in. So you'd have tangent squared theta plus 1 minus tangent squared theta. And so tangent squares will cancel. But maybe you saw it. Like, maybe you saw it. If you subtract tangent squared from both sides here, it's secant squared theta minus tangent squared theta. So you can have that. But if you don't see that that's 1, make that substitution. It should be just fine. Though, I like this even better. So, I guess I just want to say with this problem, hey, please don't forget, you can break one fraction into 2. Okay, and then the last thing I want to look at with you is this one. Secant squared theta minus sine squared theta secant squared theta. The directions I have here say factor and simplify. I think it's pretty easy to do that. Okay, did you take out a secant squared? When you took out a secant squared, what were you left with? Please don't say minus sine squared. Secant squared divided by secant squared is 1. And we have our minus. If we divide here by secant squared squared's cancel, we can do that. So I love the minus sine squared, but please remember the 1. This thing divided by itself is going to be 1. And now what about this? What is 1 minus sine squared? That's right, that's cosine squared. Hey, isn't secant squared 1 over cosine squared? It sure is. And so, those will cancel. Okay. I think this is good, and I really want you to factor. But I'm just looking at this other way of doing the problem. What if I turn that into 1 over cosine squared? Why am I thinking about that? Well, what happens when I slide these two things together? Hey, isn't sine squared over cosine squared tangent squared? And we just saw this in the last problem. That's a good one. Alright, well, let us know if you have any questions. There's on review. There's a fabulous review worksheet here that I encourage you to do. I actually have a note saying do it with a partner. I think that's really smart. I think having a study buddy on the dining table or at the coffee shop is a fabulous way to go through. Okay, well, that's it for today. Have a great day.